Okay, so this is just a review for polynomials to start out our new unit. So we're going to start with some vocabulary. So identify where the function crosses the x-axis. So we cover that in Magna Advanced Algebra, and then talk about it also when we're solving as well. So x-intercepts is the, I guess, most obvious term for where you're crossing the x-axis, but also zeros, roots, and solutions in no particular order. They just all refer to where a function interacts with the x-axis. You might have to factor the equation to identify the x-intercepts. So determine the nature of the x-intercept. We have single roots, double roots, and triple roots. So a single root means that your factor has an exponent of 1. Or in other words, you're not really going to see an exponent on that factor. And it leads to, on the graph, that it crosses the x-axis. If it's a double root, then that factor has an even exponent. And so what does that mean for your graph? It means it's tangent at the x-axis. And then if it's a triple root, then the factor has an odd exponent greater than 1, because 1 is odd, but that means that it is a single root and it just crosses. So if it has an odd exponent that's greater than 1, then there is an inflection, also known as a terrace point, at the x-axis. The tangent is not a cross, it's a touch and turn or a bounce. If it's a single root, it's just a straight cross through at that x-intercept. And an inflection is still a cross, but it's not a straight cross. It sort of levels out for a second, but then keeps going in its original direction. So we need to know about end behavior. That refers to leading coefficient and degree of the polynomial. So you can determine the end behavior from standard form or factored form. So you kind of need to know what to look for in both instances. So in standard form, that would be it's not factored at all, usually with the highest exponent term written first and then going in descending order. So it's just the coefficient on the term with the highest exponent. And we'll refer to the bottom of the page in a second. The degree of the polynomial, so if you're in standard form, it is just the highest exponent, which if it's written in standard form should be the first exponent, but you never know. And then if it is in factored form, and we want it to be completely factored, not partially factored, you want the sum of all x's and related exponents. So now let's go look at the bottom where it says about the leading coefficient. If the function's in standard form, meaning not factored at all, the degree is the highest power. If it's in factored form, you have to add the powers and multiply the coefficients. So this just basically goes back to how you have to look at it differently if it's in standard form versus factored form. So there are 4 possibilities for end behavior. We can have even, positive, And so that would be the sign of the leading coefficient is positive and the degree of the polynomial is even and positive. And all even positive polynomials go up on both ends. That doesn't mean that it just looks like a plain parabola. It could be doing lots of things between the ends, but on the left end it goes up and on the right end goes up. And that's true for all even positive polynomials. Mathematically written, we state the behavior in terms of limits, which we just finished. So we would say the limit as x goes to negative infinity. So we're talking about what is it on the left, and it's going up. And the limit as x approaches infinity is also going up. So on the left it's going up, and on the right it's going up. So then we have the sign of the leading coefficient is positive and the degree is odd. So this is odd positive. All odd positive functions go down on the left and up on the right. And again, that doesn't mean the graph looks like that. That's just what's happening on the ends. So if we state that in terms of limits, the limit as x goes to negative infinity, it's going down on the left. So we do negative infinity, and the limit as x goes to infinity, it's going up on the right. So left, down, up, right. So if the sign of the leading coefficient is negative, but the degree is even, then it's the opposite of the one above it, and it is even negative, which means it goes down on both ends. So to write that in terms of limits, the limit as x goes to negative infinity of f of x is negative infinity, and the limit as x goes to infinity of f of x is negative infinity. It goes down on both ends. On the left it goes down, on the right it goes down. And finally, we have odd and negative, which is the opposite of this one. So if this one goes down on the left, up on the right, this one is up on the left and down on the right. So the limit as x goes to negative infinity, so on the left it's going up, and the limit as x goes to infinity, that's on the right, it's going down. Okay, so that's just some quick notes. Now we're going to do some examples, and then hopefully you're able to complete your homework after that. All right, so sketch should include the zeros or x-intercepts, the end behavior, and any points of inflection or tangency. So first we look to see if it's in standard form or factored form. Number one is in completely factored form. That's nice. So I can go ahead and find my zeros or x-intercepts by setting each factor equal to 0. So we have x equals 0, x equals 2, and x equals 4. So those are our x-intercepts. You look at the exponents of each factor, and that's how you determine if it's a single root, double root, or a triple root, and what that means. So if it's a single root, so I'm not going to see an exponent, that's just a cross. If it's a double root, the exponent is even, that's tangent. And if it is an odd exponent that's not 1, that is a triple root, and that's an inflection. So we have x equals 0 is a cross, x equals 2 is a tangent, and x equals 4 is an inflection. Also need the end behavior. So since this is in factored form, the degree, I will count up the x's, including the exponent. So there's 1x. This counts as 2 more, and this is 3 more. So it's 3, 4, 5, 6. So it's 6 degree, which is even. And then as far as positive or negative, this represents 3 positive x's. This is 2 more positive x's. And then this is a negative x. So if I multiply 3 positives times 2 more positives times 1 negative, it's going to make the whole thing be negative. And so the end behavior is it goes down on both ends. So now I'm ready to sketch. I have all my information. You're only really going to label or scale your x-axis. And so I just need to represent between 0 and 4 on the x-axis. So my x-intercepts are 0, 2, and 4. My end behavior is it's going to go down on both ends, and then from left to right. As it hits the origin, it's just going to cross straight through. I have to turn around to get to 2, and when I get there, it's tangent. So turn around, and when you get to 2, you touch and turn. That's what a tangent looks like. Got to turn around to get to 4, and that's an inflection. So you want to approach it like you're going to turn when you get there, level out for a second, but then just keep going. So you can see that's a straight cross, and that is an inflection cross. All right, for number 2, it is partially factored. This trinomial right here can be factored more, so I want to do that. It's x minus 3 times x plus 2. If either of these factors had been represented again in the function, I would want to combine them to get the correct exponent, since that exponent gives us a lot of information. So I have x equals 0, x equals -5, x equals 3, and x equals -2. At x equals 0, I have that odd exponent, so that's an inflection. At x equals -5, I have this even exponent, so that's a tangent. And then once this is factored, both of those factors have exponents of 1, so they're both just crosses. For end behavior, when I count up the x's, I want to do that from the fully factored form. So this is just 1x, this is 1x, this is 2 more x's, and then this is 3 more. So I have 3, 4, 5, 6, 7. So it's 7th degree, that makes it odd. And then for the positive and negative, here's a positive x, another positive x, 2 more positive x's. And then this is actually 3 positive x's, but then I'm multiplying the whole thing times -1. So if you have a negative sitting on the front like that, whatever you would say as far as whether it was positive or negative, if that weren't there, it just makes it the opposite. So if I covered that up, all I have are positive x's, 3, 4, 5, 6, 7 positive x's, but then that's times -1. So it's going to make that whole thing be odd, and all odd negative functions go up on the left and down on the right. So when I set up my x-axis, I have to have room for 0, -5, 3, and -2. 1, 2, 3, 4, 5. 1, 2, 3. All right, I have 0, -5, 3, and -2. The end behavior is up on the left and down on the right. So going from left to right, first I get to -5. That's a tangent. So I'm going to touch and turn when I get there. So next I'm going to hit -2. I have to turn around to get there, and when I get there, I'm just going to cross straight through. I got to turn around to get to the origin, but that's an inflection. So I'm going to approach it like I'm going to turn, but then I'm going to not. And then turn around to get to x equals 3. That's another straight cross. For number 4, that also is not fully factored. That's a difference of squares. So I want to fully factor it and sort of clean it up before I make my decisions. So this is x plus 6, x minus 6. Now see how I have another x plus 6 here? I want to put those together. So I have the negative out front. I have this 1x minus 6, the 2x minus 5, and then these two x plus 6's and this x plus 6 make x plus 6 cubed. So I have x equals 6. That will be a cross, no exponent. If you set 2x minus 5 equal to 0 and solve, you get x equals 5 halves. That's also a cross. And x equals -6 is an inflection. So no tangents on this one. All right, so then for end behavior, I have 3. You don't count that as 2. We're just counting x's and exponents, not coefficients. So that's 3, 4, 5. So it's 5th degree, which is odd. And then all the x's are positive, right? Positive x, positive, positive. This negative on the front is going to make the whole thing negative. So just like number 2, it's odd and negative. So up on the left and down on the right. So I'm ready to graph. On my x-axis, I need to have room to go from -6 to +6. 1, 2, 3, 4, 5, 6. 1, 2, 3. Go far enough. 4, 5, 6. So I've got positive 6, negative 6, and 5 halves is 2.5. Going up on the left and down on the right. So if I go from left to right at negative 6, that's an inflection. So again, approach it like you're going to turn, but then keep going. So it just sort of levels out as it's crossing, but then you keep going. I got to swing around to get to 2.5 where it's going to cross. And then swing around to get to x equals 6 where it's also going to cross. Doesn't matter how low you go or high you go when you're turning, because we're just doing a sketch. So as long as the x-intercepts, the behavior, and the tangents, inflections, and crosses are on point, it's all good. All right, last one. Got a couple of things to factor here. This has a GCF, so I can plot an x, and then you have a trinomial that factors into x plus 5x minus 3. So then if I rewrite it, I have the negative. So negative x, and then here's another x that I factored out. So that's going to become negative x squared, and then x plus 2, x plus 5, x minus 3. So my x-intercepts are 0, negative 2, negative 5, and 3. These are all crosses, but the 0 is a tangent. As far as behavior, there's 1, 2, 3, 4, 5 x's, so that's another odd function. And all the x's are positive except for that negative on the front makes the whole thing negative. So it is another odd negative function that goes up on the left and down on the right. So time to graph. My x-axis needs to have room for negative 5 to 3. 1, 2, 3, 4, 5. 1, 2, 3. All right, so 0, negative 2, negative 5, and 3 are my x-intercepts. And behavior is up on the left, down on the right. From left to right, I'm going to cross at negative 5. Swing around to cross at negative 2. At 0, it's tangent. So when I turn around, I'm going to get to 0. I'm going to touch and turn, and then I'm going to turn to get back to 3 where that is another cross. All right, you should also be able to write the equation in factored form from your graph. So it's an equation. So let's start with y or f of x equals. Otherwise, it's an expression. So then I go through and write the factors based on the x-intercepts. We have negative 3, negative 1, 2, and 3. So the order is not all that important. I'm just going to go from left to right. So I have x. If it's negative 3, the factor is x plus 3. Negative 1 is x plus 1. Positive 2 is x minus 2. And positive 3 is x minus 3. It is just straight cross at each one, so I don't need any exponents. And then the last thing to check is for end behavior. This end behavior is up on both ends, which is representative of an even positive function. If I've done everything right to this point, I should have the even positive part straight. You would only need to make an adjustment if it needed to be negative, which it doesn't. So then for the next one, again, f of x or y equals for an equation. I have a negative 5, so that would be x plus 5, and it's tangent there, so I would square it. And I have positive 5, so the factor would be negative 5, and that's an inflection, so I would cube it. That's it. Check the end behavior is the last thing. This goes down on the right, down on the left and up on the right, which is what you would have for an odd positive function. So if you've done everything right up to that point, you should have the odd part covered, and it should automatically be positive, so I don't need to adjust anything for that. Last one, I have negative 5, so that would be x plus 5, and it's tangent, so squared. I have -1, that's x plus 1, and that just crossed. I have 4, so that's x minus 4, and that's an inflection, so you want to cube it. And 7, which is x minus 7, and a cross, so no exponent. Then lastly, check your end behavior. This goes up on the left and down on the right, which is true for all odd negative functions. So if I've done everything right to this point, the odd part, it should be odd positive. So if I need it to be odd negative, the easiest thing and what I highly recommend is you just throw a negative right after the equal sign, and that'll make the whole thing negative. All right, and then lastly, so I said on the curves up here, it didn't matter like how low or high you went before you turn, because we're going to use our calculate for that. And so this is just where you put it on the calculator and then answer questions about it. So let me bring up the calculator. So I'm going to put in the function into y equals -x times x plus 3 cubed times x minus 1 squared. And then you might have to adjust your window. Zoom 6 is always a good first try. So it looks like I don't need to see a lot of this over here or a lot over there. But most importantly, I need to see where those turns are, because that's where I'm going to get a lot of my answers. So I'm going to go back to my window. It looks like I need to see higher. If I go back to the function, I should be able to determine that there's a 6 x's and there's a negative on the front. So even negative means it goes down on both ends. That means that these ends are just probably going down. There's nothing like that I'm missing there. But obviously there's a turn up here that I need to see. So I'm going to get rid of some of this stuff happening on the sides. And that was empty space. I don't need to see any lower, but I need to see higher. I usually just double it the first time and see what that gets me. So I need to see a little bit higher. So I'm going to go back to the window. Maybe I'll double that again. That seems to be good. I could even go back and get rid of more of this. You don't have to, but just makes for a nicer graph. Okay, so remember the questions that I'm answering. It says determine all, let me do this. Determine all max min values, intervals of increase, decrease, and zeros of the function. Specify where the function is less than 0 and greater than 0, and use interval notation. So I'm going to do a quick sketch of my graph. Doesn't have to be the most wonderful thing. You can see here, the calculator can tell you where your x-intercepts are, but you can tell from your factors here that you've got 0, -3, and 1. And it is an inflection at -3, cross at 0, and a tangent at 1. Okay, so you just want to have a sketch that you can see right there on your calculator as well. So for this one, if I want the calculator to find my x-intercepts, I'm going to do second and then the trace key and 0. And it'll ask you down here your questions. So like if I want to find this one over here, again, you should know from function, but just in case. So it just wants you to go somewhere to the left of the x-intercept, then it changes the question. Now it wants you to go somewhere to the right of the x-intercept. Hit enter again, and it'll tell you that it's -3. Let's see what it does if for the origin though, because sometimes it won't give you 0. Let's see, maybe it will. So somewhere to the left of the origin, somewhere to the right of it, hit enter. Nope, it gave us 0. Sometimes it gives you like a decimal with E and it means 0. So, all right, I have my x-intercepts. I need where my turns are. So I have a maximum turn and a minimum turn. So I'm going to ask the calculator to help me with that. So first I'm going to do my maximum, just going left to right. Again, it's going to ask you those same questions. Point to the left of the maximum, hit enter. Point to the right of the maximum, hit enter where it says guess. So this point right here is negative 1.237, comma, 33.920. Then I'm going to use the calculator to find the minimum, which is 3. So point to the left of the minimum turn, point to the right, and this turn is 0.404, comma, negative 5.660. Then that's helpful because now I can answer all of the questions. So it asked for max mins, increase, decrease, zeros, and less than 0, greater than 0. So relative max, there's only one. It's up here, but you're going to have to answer that at 33.920 at x equals negative 1.237. So you always do your max and mins, the y value of the turn at the x value. All right, and then relative minimum. So, oh, I forgot that one. This would be a relative max as well at 1, 0. So add that in there, 0 at x equals 1. Kind of tangent is a turn. An inflection is not a turn, a cross is not a turn, but a tangent is both an x-intercept and a turn. So a turn here, and then the tangent is also a turn. Relative minimum is the one down here, so negative 5.660 at x equals 0.404. All right, your intervals of increasing and decreasing. So I kind of do those together because I move from left to right. So it's starting on an increase. So it's starting negative infinity to the first x-intercept. Then as soon as it gets to the term, it switches to a decrease. So the decrease is from this x to this x. Then it switches back to an increase from this x to this x. And ends on a decrease from this x to infinity. Even though it's going down, increasing, decreasing is left to right. All right, so then it also asked for the zeros. I'm running out of room, so I'm going to use my paper here. The zeros you can state as a set. So we have negative 3, 0, and then 1. And then you're going to use those. So max, min, increasing, decreasing is all about the turns. Then the greater than and less than, that part is using the zeros. So we would have f of x less than 0 and f of x greater than 0. So from negative infinity to negative 3, it's below the x-intercept, so it's less than 0. It's less than, so we use a parentheses. If it's less than or equal to, we'd use a bracket. Then it's above the x-intercept here, so that's from this x-intercept to that x-intercept, negative 3 to 0. Then dips down below from 0 to 1. And then it stayed there, but because it's just less than, I have to do 2 separate intervals from 1 to infinity. Okay, if it said less than or equal to, I could just say 0 to infinity, but it doesn't include the x-intercept, so I have to break that up into this section and that section separately. All right, one more example. So I'm going to go back to y equals and type in my last problem, x plus 2, x minus 5 cubed, and x minus 1 squared. So again, this one is already factored, so I really shouldn't have any questions about where the x-intercepts are, but if you just want to double check, the calculator will tell you. I don't really know what window I want to use here, so I'm just going to hit graph and hope for the best. All right, so if I look at this equation, it is also even and positive, so it should be going up on both ends. So I'm going to go back to like zoom 6 and kind of start over. So this end must be the left end going up, and that's the right end. So I probably don't need to see anything up here, but I definitely need to see lower. And it looks like I don't really need to see all of this. So I'm going to adjust my x min to -3, do my x max at 6. That's not like the answer. That's just a choice I'm making. Definitely need to see lower. And I've done this problem before, so I'm just going to go ahead and put in what I know is going to work just to speed things up. And because that is so low, I want to balance it out with sort of something is in the same family for the y max. Otherwise, it's gonna be awkward and hard to look at. Okay, if you feel like you want to see more there, of course, like you can always adjust the window to see more. You need to see the x-intercepts and the turns. So I should know the x-intercepts just because they gave me the factored form. I can see this minimum. Here's a maximum, another minimum. Remember, a tangent is both an x-intercept and a turn. An inflection is not a turn. All right, so on my paper, I'm going to do, again, another little sketch. Looks like I need more here. I know -2 and 5, so got x-intercept of -2, 5, and 1. And looks like it goes pretty low here. Its tangent doesn't go very low and then ends on an inflection. So let's see, a tangent is also a turn, so I want to go ahead and label that. But if you're not sure, you can check it, with your calculator. I'm going to find this minimum from the calculator. So it just wants me to go someplace to the left of the turn, hit enter, to the right of the turn, hit enter, and then, so this point right here is -1.266 and -927.229. This turn, which is also an x-intercept, I knew from what they gave me. Remember, you can also have the calculator find it. That would be a maximum turn. So point to the left, point to the right. Okay, so instead of just giving me 1, which I know is the x-intercept, it gave me this. It also may give you like 0.9999999, but it means 1, and we know it's 1. This is what I mean, like instead of 0, sometimes it gives you a number like this with E in it, but it means 0. So how to interpret this right here, it's a 1, 0. Again, on someone else's calculator, it might give you 1, 0, or it might give you here 0.99999, but it all means 1, 0. All right, and then I still have to find this minimum turn. And so this turn right here is 2.766 and -165.724. All right, so once I have all my x-intercepts and all of my my turns, then I can answer the questions. So starting with relative max and relative min. There's only one relative max turn, so 0 at x equals 1. There's 2 relative mins because there's 2 min turns, so -927.229 at x equals -1.266, but also -165.724 at x equals 2.766. All right, then I'm going to do the increasing, decreasing. All right, so starting with a decrease here, so it's -infinity, and then I would use the x coordinate of that first turn. then it switches to an increase. So it's going to be this x coordinate to that x coordinate, switches to a decrease. So from this x to this x, and then it ends on an increase from this x to infinity. My x-intercepts, and running out of room, so my zeros were -2, 1, and 5, and that should allow me to figure out f of x less than 0 and f of x greater than 0. So this is above the x-axis, so that's greater than 0. So that would be -infinity to -2. And if that were an or equal to, then I would put a bracket here. Then it dips below the x-axis from -2 to 1. It's staying below the x-axis, but since it wasn't including the x-intercepts with the or equal to, I have to break that up into two sections. If that did say less than or equal to, I could do from -2 all the way to 5. But because it doesn't say or equal to, I have to do this section and then this section. And it ends on an increase from 5 to infinity, which is also above, that's where it's also above the x-axis. So, all right, so that should help you review and be able to complete your homework. And we will then, that's all for Magna Maths Algebra, and then we will talk about the what is new for polynomials in pre-calculus next class.